Gentlemen and Kylie, good morning. Good to have you here.
What's up, Mr. G?
Hey, we have, Hannah should be joining us shortly. We have right here differentiation by the chain rule classwork, and this is sort of a review on what we worked on, I think, last Friday. Basically, you have these 5 situations. This first one here would be pretty easy to expand, and we could take the derivative of that pretty readily. The second one here, you could also do that, but you can see the expansion of the third power is going to create more work to that. And then C would be possible, but extremely tedious. We'd have to it would just be a long binomial expansion. And then D, we could not even do without what we call the chain rule. So I want you to go through these exercises with me. We're going to do these without the chain rule and with the chain rule. And so the first thing you're going to have here is to expand f of x. And to do that, we would have the first term squared. You remember from the binomial expansion we did last year? So here's the first term squared, which is going to be 4x squared. And then we have plus 2 times the first and the last. So what is that going to be, like 20x?
Yeah.
20x, and then plus 25. And if we take the derivative of this, f prime of x, we get 8x plus 20. Does that sound right? Does that look right? And then we can do this without the chain rule, with the chain rule over here. If we have f prime of x is going to be equal to 2, we have 2x plus 5 to the power of 1, and times the derivative of the inside, which is, what's our derivative of the inside?
2.
2. So what we would have is, we would have f prime of x would be equal to, that'd be 4. Two times 2 is 4, so you have 4 times 2x plus 5, and we distribute that, we get 8x plus 20. Now, which way was easier to do it?
I don't know, to me, without the chain rule.
Without the chain rule?
Yeah. I did it faster like that.
Yeah, I'm kind of thinking that too, and the reason is because I'm more familiar with this binomial expansion, but you notice when we did the chain rule, we had to do a little bit of expanding to get to the same thing. But we got the same thing, and that's part of the demonstration of this, right? Let's go on to the next one here. We have there we go. And what happens is, I'm not even going to have you do this without the chain rule. I want you to do this with the chain rule. We can, well, you go ahead and do this with the chain rule. To do it without the chain rule, you'd have to do a binomial expansion. Yes?
Wondering when you are having another test.
Pardon me?
When you are having another test.
Probably after the normal normal lines.
Yes.
Class is happening, right? All right. Yeah, probably after, because we have to still go through normal lines. So we have this next packet and probably a little bit after that.
Not this week.
Probably not this week or next week.
Oh, we're gonna get real close to that second test period at that 9 weeks.
No, but that's gonna be, probably after our fall break will be our next test.
Oh, so what's our next test rate for this?
Pardon me?
What's our next test rate for this 9 weeks gonna be? Or does the fall break happen before this 9 weeks is over?
No, I think it's consistent with the 9 weeks. I think that's the end of the 9 weeks.
Okay.
Yeah. And so so we'll be through, it's just where I have the tests located.
Okay.
You're telling me.
So anyway,
I only have 2 weeks till fall break.
so what did you get for with chain rule? You got f prime of x equals
My first, 3,
3
2x plus 5
squared,
squared, and then times 2.
and then times 2. And so you end up being 6 times 2x plus 5 squared. And you can expand this out, but one thing I like about the chain rule is that do you have to actually expand this out?
No.
No, you really don't have to. This is actually a complete answer. So when you go ahead and expand this out, you're going to have that binomial expansion situation. And I don't know if you remember this from last year, to the third power, it's going to be a cubed plus, I think it's 3 a squared b plus 3 ab squared plus b cubed, and we can apply that with all this here. But you can see that's going to be a little bit tedious, isn't it? Mm-hmm. And then tedious but feasible, but then you get bigger. Okay, this thing here, using the chain rule, keeps from the tediousness spiraling out of control in a lot of situations. So it'll be very helpful to us. And then you have the situation that I mentioned at the beginning, D, where we really can't expand and do that with the chain rule. Let's see where this is. Yeah, this example 4, for example. Okay, we have to use something like this. Now this one here, go ahead and do example 3 first. So Hannah, using your calculator to help with arithmetic a little bit on that? Yeah, okay. Okay, this one here for 3, and maybe I'm wrong, but I'm sort of thinking that's going to be 20 times 2x plus 5 to the 9th power. Is that right?
That's fine.
Yeah, because the derivative of the inside is 2 in 10 times 2, so that's it. But now we come to this guy over here, example 4. And again, we could have expanded this out. Now, it would have taken half the class period or more to do it, really. But, so this definitely made our life easier as far as doing that. Now here, what you have is, do you know how to expand this out to differentiate by parts? You really can't do that, can you? So you have to go ahead and take this to the 1/2 power, and how do we find the derivative using the only way we can? So this is going to be
which is
1/2
2x.
2x plus 5 to the,
Um,
Would be the negative 1/2.
and times the derivative of the inside, which is
yeah,
2.
2. So you have the 2 and 1/2 cancel each other out. So you're going to have so that's going to be what you have for this. Okay. Questions on any of those? Just examples, practice of this. Now, okay. I want you to do 6 first, then 5. We'll do both of them. We'll go over this pretty quickly.
6 and then 5?
Yeah, 6. I think 6 is a little easier than 5, probably. But 5 to me is an interesting one too. Okay, for this one here, y prime, so what do we do here first? Take that 3 and do what with it?
Okay.
Multiply out front.
Yeah.
And then what?
2
What do you say?
n squared.
What is our derivative of the inside here?
1 to 3x squared minus 2x plus 1b squared.
I'm thinking 6x minus 2. So I really, because the way this is, sometimes you can just kind of multiply these things together, but I can't. So to me, that's our answer. Okay. Okay, take a look at number 5. Did anybody do number 5 yet?
No.
5 gives us from what we've done so far this year some options. One way you could look at this, you could read y as a 4x minus 3, the negative 1 power. And if you apply the chain rule to that, what do you get for that? Negative 1 times to the what power? Negative 1 minus 1.
0.
Negative 1 minus
Oh,
1.
negative 2.
Negative 2, thank you. And derivative of the inside. What is our derivative of the inside? 4. 4. So we get negative 4 over 4x minus 3 squared. Okay, now, one way you could have done this, how could you have done this alternatively, according to what we've done so far this year? There's something we did that starts with a Q. A quotient rule, okay? So using quotient rule, y prime is equal to low d high. And what is d high?
0.
0 minus high, and high is 1, d low, which is 4, right? All over low squared. And you see what we get here? Negative 4 over 4x minus 3 squared. So different technique, and you can do this as a product rule too. Do you know you can do this as a product rule also?
I bet you could.
Yeah, product rule. What you have is you have a product of two functions, 1 times 4x 3. So you say y is equal to 1 times 4x minus 3 to the negative 1 power, and then it ends up doing the same thing. Okay? Now, okay, find the derivatives of the following. Okay, what I want you to do is do number 7 here. And number 7. And
I don't know what I was thinking. I think I was waiting for something to happen because you just...
so are you okay? Are you okay,
Yeah, I'm
Hannah?
fine. I was just like,
Yeah.
I just zoned out.
yeah.
Yeah, that's
You
fine.
said do number 7, but then you clicked something on the computer. So
Oh, okay,
I
all
was
right,
waiting on
all right,
something.
all right. That's fine. Yeah, I just resized it a little bit. That's all. Well, what happens to this 2/3?
Negative 1/3.
Yeah.
It just comes up front here like this. And what'd you say, Gavin?
Negative 1/3.
Yeah, so we're gonna go ahead, and this is gonna be to the negative 1/3 power, okay? Times what?
4, negative 4.
Negative 8x, right?
Oh, yeah.
Derivative of the inside, negative 8x. So just kind of putting this together, we got negative 8x times 2, so it's going to be like negative 16x over 3. We have cube root of, what is that, 7 minus 4x squared? Harris. So that's what it should be, okay?
Okay. That
Yeah.
makes sense.
Did anybody get that?
I got
No, no.
the first
Not
part, but
quite.
I hadn't like worked it all the way out yet.
So is this like the details, or the details putting things together, escaping you a little bit?
That was -4.
Oh, this was -4, yeah. Well, you gotta have the, what you have the 2 times 4x times -4x, so that's where that -8x comes from, okay? So, it's getting used to things. Then we have other things like this one with 8. You take -5, and then you make this x squared minus 4x plus 1 to the 1/2 power. And then you apply your chain rule here, right? Times 1/2. And then that's going to be to the -1/2, and then times the derivative of the inside. This one here is going to be y equals -2. Actually, I got it right differently. I'll put 6x minus 1 to the -1/4 power, right? And then work that out. And so you can just go through the process, but you can see that we have to do the rational, radical conversions and be able to go back and forth. All right? Okay, let's go on to next here. And can you see as we go through these that they require us to put together things we've done in the past? For example, these ones here are, this also explains the chain rule is not a basic rule of differentiation. Chain rule is always in effect. So even when you have y equals 7x, your answer is 7 times the derivative of x, well, the derivative of x is 1. And so here, what is facilitated is putting these different things together. So I want you to find the derivatives of number 10.
I didn't bring any more camera in.
And for number 10, could you expand that out and make it an easier problem?
Yes.
You could,
Oh,
but is that to expand to the 4th power? Okay,
now I'm thinking.
we only
about it.
have 15 minutes of class left, right? I mean,
I think he's way wrong with that one, man.
are you done with it, Gavin? Okay, let's check it out. What I'm doing is I'm looking at a product of 2 functions here. So I'm going to go right over here and say, okay, well here we have x squared, and derivative of x squared is 2x.
Oh yeah, I'm right here.
And then we have 2x minus 3 to the 4th power. And derivative of all this is going to be 4 times that, the inside, times the derivative of the inside, right? And what's the derivative of the inside? What's the derivative of our inside here? 2, right? So we'll have 8, which is 2 times 4, 2x minus 3 to the 3rd power. And now we can just put these together. Y prime is equal to that, these things multiplied together, plus these things multiplied together. So you'll have I'm gonna write down here just to leave more room. So I'll have 8 x squared. I have 2x minus 3 cubed. And then plus these things multiply together, 2x. And we have 2x minus 3 to the 4th power. And then one thing you have here that you could do is you have common factors all over the place.
I'm using this as a calculator, we can line done.
Yours died. You need to have recharge. Yeah, I got a charger up here someplace. I'll get you charged in a minute. Okay, your common factors look like you have 2x, and then this 2x minus 3 cubed, and then that's going to be times what, 4x, and then we have plus 2x minus 3. You see what I did here in the factoring? This is what's remaining out of here, and then this is what's remaining out of this after factoring this out here. So this will help you when we're going to need to, later on, we need to find zeros of a derivative. Anyway, that's that one. Okay. But again, putting a couple things together. For this one, number 12, you'd have a quotient rule of the derivative of the inside. So you can have 5 times all this to the 4th power times the derivative of that. Okay, which is going to be, that will take some time to do. But okay, we have some more exercises here. Yeah, these are different. This has f of x and g of x and allows us to put together different things. I want you to look at these ones right here. Answer the question is, if we look at these columns here, so this is sort of an analysis thing. What kind of rules and would you use for solving these types of problems? For number 1, what kind of rule would you use for this one? To say chain rule or product rule or both?
Chain rule.
Just chain rule? I'm kind of on that. I'm thinking chain rule. And then if we have this one over here, what is this going to be?
Product.
Yeah, product, but we still have to have the chain rule, so this would be both, right? And then we have this one here, number 2. Same, right? Chain rule. In fact, chain rule is going to be the same for all of these. What about these ones here? Both, right? So on the back of this paper, find the derivative of number 1 and number 5. So just work those out. Number 1 and number 5. Work those out. Let's see if I got here. Oh man.
Can I get the rest of them, please? One and what? 5?
Yeah, capital.
Did I do one right?
Yeah, but we only have 11 minutes left, so I'll just charge them. Thank you, but
Hey, sure. For this text correction, did you say you posted the new for it?
Yeah, I did.
Okay, I was looking for it.
Yeah. And really, it's really a surprising thing, because that video of the test review has had like 19,000 views in 5 years. Can you imagine? A test
Did
correction
you make money for that?
Actually, yes. I mean,
Is that the top of your, like if I go to your YouTube channel, it's the top right to like search for?
yeah, I'll show you. I can show you where it is. It's called Limits and Continuity Test Review. I'll show you by the end of, I'll show it right now. Yeah, since I went to monetizing videos starting during the spring break, I think May was the first thing so we had, let me get to my page here, YouTube Studio. So limits and continuity. Yeah, this is it right here. Carson, this is it right here, limits fall, so it's fall 2020, fall 2015.
So this is the same test from 5 years ago?
Yeah, I made it, what happened is, what happened was I made the test.
Because I think once people learn about it, why wouldn't they take it?
Sometimes the deepest memories come from just below the surface. You can taste it. See?
Yes, I can taste it.
Of h of x. And so here we are at x
So that's
equals
it.
4. And so from the left
Oh, I said 20,000, 29,000 views. What happened, I made the test, I remember making it, I was going with a friend to help him out. He was a disabled friend, he was going to an archery range out in Fort Worth, Cinnamon Creek. I don't know if you've ever heard of Cinnamon Creek. It's an archery and ballistic place out there. And I just sat out in the car while he was there and just made this, I made the test. So anyway, what I want you to do is that you see this where it says differentiation by the chain rule homework, you see that? Okay, here we go, 1 through 10. Differentiation by chain rule homework 1 through 10. You can start working on that, all right?